All right. Good afternoon, people. Once again, it is 1 p.m. in the afternoon, and we are here. I guess, we were doing a few engineering mathematics questions. Yeah, I kind of started loving math, man, to be honest. Where are we? Where are we? Where are we? We are here, and I am aiming for doing a 4 hour stream today. This session, I guess. Yeah, I got my water bottle here, and so there is there is no reason to wake up and everything. So yeah, convolution. Yeah, that's enough. So n greater than one, the maximum multiplicity of any eigenvalue. What is multiplicity of an eigenvalue? Multiplicity describes how often an eigenvalue appears and how many times, how many independent eigenvectors it has, algebraic multiplicity and geometric multiplicity. The number of times an eigenvalue occurs as root of matrix characteristic polynomial is known as algebraic multiplicity. The geometric multiplicity of an eigenvalue is defined as the dimension of eigenspace associated with that eigenvalue. Okay, okay, okay. The number of times the eigenvalue is repeating. Multiplicity, algebraic multiplicity, number of times eigenvalue is repeating. Can repeat n times at maximum. Okay. Simple, simple, simple. N is greater than 1, consider n by n matrix M whose elements are let the vector 0, 1, belongs to R of n with a null space of M. Right. This is the vector is a null space. There is one non-trivial solution. Okay, no idea. But हमको हमारा भाई चैट जीपीटी है ना Claude. Let's see how good and how long does Claude performs on tasks like this. Okay. Nice, right? An n matrix with M, the vector is null space. The null space of M consists of all vectors. Null space. Null space of M consists of all vectors V such that M is equals to 0. Example 0, 1 is in null space M times 0, 1, 0 whole transpose is equals to 0. This tells us the second column of M when multiplied by 1 and everything else by 0 gives 0. The second column of M is a 0 vector. When second column of M is multiplied by 0 gives 0. If M has a 0 column, so second column of M is a 0 vector, then that M is equal to 0. Since 1 cannot say anything about non, there are at least two non-zero vectors. There are two non-zero vectors in null space. Multiple of 0, 1 is null space vector. Is it correct? Okay, that checks out honestly. You have learned about null space. Okay, this is a function c1 plus c2. You need an integral answer. C1 e power x minus C2 log e 1 by x if x is greater than 0, 3 otherwise C1, C2 belongs to R. X is continuous. X is equals to 0. Sorry, I mean F is continuous. X is equals to 0. So limit x tends to 0 minus is equal to limit x tends to 0 plus, right? C1 e power x minus C2 log e 1 by x is equals to 3. If the limits are to be satisfied, right? Okay, we kind of written it. No, that is majestic handwriting. Right, okay. If C2 is equal to 0, then 1 by 0 will be 1 by 0 term will be finite. C1 is equals to 3. So for the okay, somebody else wrote that as well. Yeah, the handwriting is indeed majestic. Hmm. Okay, the function is defined as follows: local maximum, local minimum, differentiable, continuous. You need to do the derivative test, right? For it to understand how it performs. F of x is equals to mod x by 2 minus x minus mod x by 2. Okay, my guy is here again. Let's see how ChatGPT is going to solve this question. Both graphs are downside parabolas. How do you know that? Okay. It is 2 marks, thank God. So modulus generally contains two cases for x greater than 0, mod x is equals to x. So x by 2 minus x into x minus x by 2, x square by 2 minus x square by 4 minus x square plus x square by 2 minus x square by 4. Okay. For x less than 0, mod x is equals to hmm, minus x. So that will be minus x by 2 minus x plus x by 2. Let's cross multiply minus x square by 2 plus, sorry, minus x square by 4 minus x square minus x square by 2. Let's kind of do the LCM. Minus 2x square minus x square minus 4x square minus 2x square. 6, 8 minus 9x square by 4. Okay, that makes sense. So f of x is equal to minus x square by 4 if x is greater than or equal to 0, minus 9x square by 4 if x is less than 0. So downward parabolas. One way to see them. Since x square is greater than or equal to 0, if s local maximum, how to check it? Since x square is greater than or equal to 0, f of x is less than or equal to 0 for all x. X square is always positive. Okay, that is correct. And for b, no local minimum. Okay. F dash is continuous over R. F dash of x is equals to minus 2x by 4 minus 18x by 4. To prove continuity, we must check LHL is equals to RHL. Check continuity at 0. Both are 0. Yes. So to check differentiability, differentiability of f dash. So again differentiate it. F double dash of x is equals to no. So not differentiable. The question asked for not differentiable. So A, C, D are true. 23 minutes already. Uh, so 1, 2, 3, 4, 5 more questions. That is it. We will be doing it. Maybe doing them again is not wrong. So don't worry too much about it. Okay, this thing got stuck. My ambition for today would be to complete the entire 2026 set of papers. We need to check the general aptitude. We completed these two things, and we have one, we have two, we have three, we have four. Okay. The PYQs for artificial intelligence were not provided yet. Computer networks. Yes. Trust me, people, we can do this. Logical schema, physical schema, external schema. Logical schema is used. Physical schema. One L. What the fuck? Right. Okay, it is not a big deal. We will do them when the time comes. So as of now, we are doing this, right? Yes. Here we are. GVE is simple undirected graph vertex cover such that for every u comma v belongs to E, u belongs to v dash or v belongs to v dash. Let the size of the smallest vertex cover GBK. Let S be every any vertex cover of K. The following constant will always ensure V belongs to S. A simple. It is enough of a graph. Vertex cover G is subset of such that for every u comma v belongs to address u belongs to v bar or v belongs to v bar. So for example, for this edge either this vertex should be present. For example, if you consider something like this, right? If you consider this and this and this and this and this, it is a cover. It is okay. That is too small. It is covering. The degree of V is at least k plus 1. What is degree V? The degree, the vertex V is on the path is on a path of length k plus 1. There is no mandatory for existence of a path. A vertex V is part of a clique of size k. A vertex cover as must contain at least one endpoint on every edge in the graph. Okay, for any vertex, it is guaranteed. A vertex cover G is a subset of okay, for a vertex which is the form ensures that the V is a subset. V belongs to S. What is S? S is the vertex cover. So what ensures that the vertex always belongs to the vertex cover? That is what we are being asked here. How to track this thing? Yeah. Degree is equals to my guy is being delusional. He's being very delusional here. 4 2. Mm-hmm. 4-0. Okay. Guess we will take the photo of this. We will ask ChatGPT. Okay, it is hurting my head, obviously. It is a two colorable problem. I think we had enough of this math.